Hello, my name is Professor Mike Hughes. Today, in this video, my team and I are going to show you just how simple it is to do electrophysiology using the Deptec 3DEP.
When starting your 3DEP software, the first thing you'll want to do is turn the kit on, and that's found on a power switch on the back. When the kit's on, the light on the front of the kit will turn on. You'll also hear the kit turn on, and once that happens, you can start your 3DEP software. Once the software boots up, the first thing you're going to want to do is go into Tools, Preferences, and select the COM port that your kit is connected to. The next thing you'll want to do is change your default path to wherever it is you want to save. It's important to save to a folder that you know isn't being accessed by anyone else. So for instance, if you're saving to a shared folder, you're going to want to save to a different path first, because if that's being accessed while the software is trying to save to it, it will cause the software some problems. So once you find your folder, and we'll just save to the desktop in this case, you can then start adjusting your settings. So one of the settings that you'll adjust is light intensity. You'll only need to vary light intensity between 29 and 31 normally. Normally 30 is an okay default setting, but you may find if your sample is highly concentrated or has a low concentration, you may need to adjust this. And we'll look at that in a little bit. Your capture interval is defaulted at 1 second, and you'll leave that alone. These boundary value for automatic fitting, they're tick boxes for fixed values and then unfixed values. These can be adjusted at any time, and you can also do this after you collect the data during your analysis. So you can leave it as its default setting for now and adjust that later. If you want to adjust it right now, you'll just click on the variables that you want fixed, so much like cell radius. And the ones that you don't want fixed, you'll just input a range of values that you'll want the model to fit those to. The next thing, especially if this is your first time running a cell type, you'll want to save images. So what this does is every image is saved every second for this capture interval. This way you'll be able to look back on your data and look at the images to make sure that the kit is working properly. So we'll click Save Images. It defaults to wavebands by area, just leave that the same, and you'll click Save. Now you're back at the normal screen for the 3DEP software, and we'll start the experiment. In order to view inside the kit, you'll press Preview Video. Okay, so there's a chip in the kit right now, so if we open that up, you'll see what the kit sees. So if I move the chip back and forth, you can see that happening on the preview window screen. In terms of the light intensity, if we take the chip out, you should get a semi-gray background if the light intensity is okay. Like I was saying before, you can adjust the light intensity, so through Tools, Preferences, and if we lower this to 29 and we press Save, if we stop the preview and then start the preview again, you'll notice now the preview window is bright white. You don't want bright white, so if you see this, you'll need to readjust your light intensity values. So again, Preferences, and we'll set that back to 30. Raising it to 31 will make it darker. Press Save. Stop preview. Start the preview again. Okay? When you're setting up your experiment, you'll also need to think about the frequencies that you're applying. So there's the lowest frequency field and the highest frequency field. If this is your first time with a cell type, what you'll want to do is start from 1 kilohertz and go up to 20 megahertz. So in this field, you'll put in 20,000 kilohertz for 20 megahertz. We typically run our experiments for about 30 seconds. When you would want to make this shorter is if your experiments are time sensitive. So for instance, if you're doing a drug trial and you want as many experiments done as possible in the shortest amount of time, you can make this shorter, provided that your cell types are larger cell types. So what we found is 10 seconds is typically okay for most mammalian cells when you're looking at the data analysis. However, for smaller cell types like red blood cells, and even smaller, we've done some nanoalgae particles, you need to look at longer intervals of time, 20 seconds, 30 seconds. So it's always better to collect more data than you think you need, which is why we tend to take 30 seconds for all of our data types. The signal voltage is 10, which is default, and your chip type normally defaults to your 805 chip. Once you run this frequency sweep, you can then determine how your distribution between your negative force points and your positive force points look, and you can adjust your lowest frequency and highest frequency based on that. So if you're looking at a crossover frequency, or what we call the dispersion, if that happens where you're not seeing any negative points, for example, you may need to adjust your lowest frequency. If you're seeing too many high frequencies, you can adjust your high frequency to be lower. But this is a standard range that works for most cells. Then we'll load our chip and we'll start the experiment.